Hello, everyone. Thank you for joining. Welcome to Dev Week Cloud. Up next, we have Francois, who's a senior developer advocate for Amazon Web Services, and he'll be giving a talk on Blazor WebAssembly on AWS. Take it away, Francois.
Thanks, Will. Hi, everyone. Thanks for joining this session. So we will discuss Blazor WebAssembly application on AWS and what you need to know to make your Blazor WebAssembly application on AWS successful. We will first discuss what is WebAssembly and what is Blazor WebAssembly. We will review together what are your hosting options for hosting your Blazor WebAssembly application on AWS. We will discuss how to interact with AWS services from your Blazor WebAssembly application. And finally, I will go through a demo of a Blazor WebAssembly application deployed on AWS and share with you some code to illustrate what I've discussed before. Before going further, let's introduce myself. I'm François Boulteruche. I'm a senior developer advocate at AWS. I'm focusing mainly on .NET developers. So if you're a .NET developer and you have questions, you have feedback on .NET on AWS, feel free to reach out to me on Twitter or LinkedIn. I will be happy to answer your question and to collect your feedback to make AWS better for .NET developer. So let's move on. Okay, that's it. So let's review together what is WebAssembly, and let's simply read the definition of you can find on webassembly.org. So WebAssembly is a binary instruction format for a stack-based virtual machine. WebAssembly is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. So I think what is important here is that WebAssembly is not another programming language. Sometimes people make this mistake. It's not a programming language, it's a binary instruction format. It's a compilation target for existing programming languages. For example, you can write a Rust application and compile this application to WebAssembly, and you can run this application into your browser. Same for C++ and same for C# and .NET with Blazor WebAssembly. And we will discuss this a bit later because there are some specific here. The other important part is enabling deployment on the web for client and server application. At the very beginning, Blazor WebAssembly, was designed to run inside the browser and to offer a developer to use other programming language other than JavaScript. And WebAssembly popularity is growing, and now you can find WebAssembly runtime that allow you to run your WebAssembly application outside the browser. So really now it's for client and server application. So now let's discuss what is WebAssembly. Blazor, the primary goal of the initial goal, of WebAssembly. The first goal was to be efficient and fast, and as it has been designed for the web, they pay a lot of attention about designing a binary format which is efficient from a size and load time perspective. And it also takes advantage of common hardware capabilities that you can find on most devices where Blazor WebAssembly will run. The second design goal was to create something open and debuggable. And for example, you can compile to a textual format. So there is a textual version of WebAssembly, for debugging and testing, so that you can read the result of the compilation. It has been designed to be safe. WebAssembly describe a memory-safe sandboxed execution environment, and most important, it has been designed to be part of the open web platform. So WebAssembly maintains the versionless, feature-tested, and backward-compatible nature of the web. The open web standards for WebAssembly are developed in W3C community group and a W3C working group. So WebAssembly is really part of the open web platform. It's and now it is shipped in 4 major browser engine: Firefox, Chrome, Edge, and Safari. So what is Blazor WebAssembly and how it is related to WebAssembly? So Blazor WebAssembly is a single-page application framework like Angular, React, or Vue.js, and it allows you to build interactive web user interface with C#. So you use a mix of a markup language to define your page, and C# code to define how your application will react to user interaction. It is built on open web standard because it is built on top of WebAssembly. So how it works? By default, your C# code is not compiled to WebAssembly. The .NET runtime has been compiled to WebAssembly. So there is a version of the .NET runtime that has been compiled to WebAssembly, and it can be executed inside a browser. And so your C# code is still compiled to intermediate language, and when you navigate to a Blazor WebAssembly application, the .NET runtime is loaded, and then the .NET runtime starts to interpret your intermediate language and to run just-in-time compilation to execute your application. That's the default behavior. Now they've introduced, and they will continue to go in that direction, they've introduced ahead of time compilation so that your code is compiled directly to Blazor WebAssembly, sorry. So now you have these 2 options, but the default option is still to compile your application to intermediate language and to execute your application on top of the .NET runtime which is compiled to WebAssembly. The good things with this is that you can share code and libraries between your client-side application and your server-side application, because it's C# and .NET. But if you're missing something, you can still use JavaScript interrupt to call JavaScript function from your C# code running inside the browser. So that's Blazor WebAssembly. Let's see now how you can host your Blazor WebAssembly on AWS. First, Blazor WebAssembly come with 2 flavors. You can build a Blazor WebAssembly standalone application. So basically, it's a single-page application which is static content. So like an Angular application, single-page application, or a React single-page application. It's static content that you can host, for example, on Amazon S3, our simple storage service, and distribute through our content delivery network, CloudFront. So this option is the easiest and cheapest option if you've built a Blazor WebAssembly standalone application. The second flavor is to build Blazor WebAssembly ASP.NET Core hosted application. So in this case, your project has a backend, a web API backend that will serve your Blazor WebAssembly application. And you need a hosting service to host your backend. So for public-facing application, I would recommend to take a look at AWS Runner. It's an AWS service that allows you to run containerized application behind a load balancer without having to manage the underlying infrastructure. You just ask the service to run your containerized application behind a load balancer, and it manages everything for you. So if you containerize your backend applications that will serve your Blazor WebAssembly application, it's very easy. And in the case you are not building a public-facing application, but for example, a non-public-facing application, a line of business applications that will be used on your corporate network, you can use Amazon Elastic Container Service with AWS Fargate. It will allow you to run your container on serverless in a serverless way, so you can run your container without worrying about the underlying infrastructure. Sorry about this. So that's your option. You have many options, but if you start with AWS, I would recommend to first give a look at this option, and if you have other requirements, then you can dive deep on other hosting options. Now we've seen how to host our Blazor WebAssembly application on AWS, but how we can interact with AWS services from Blazor WebAssembly. And here I must say that at first it's not good news. Regarding authentication, our authentication service for end-user authentication is Amazon Cognito. And here we have an issue. Blazor preferred authentication is built on top of OpenID Connect. And by design, Blazor silently logs in to your OpenID Connect provider. But unfortunately, Amazon Cognito doesn't implement the prompt equal known parameter from the OpenID Connect specification, because Amazon Cognito is not a fully OpenID Connect provider. Amazon Cognito is able to integrate fully compliant OpenID Connect provider, but itself, it is not a fully compliant OpenID Connect provider. So if you try to use Amazon Cognito as your OpenID Connect provider, you will experience a 10-second timeout before reaching an issue, and so it won't be a good experience for your user. The second issue is that you can't use the AWS SDK for .NET in your Blazor WebAssembly application, and let me explain why. When you make a call to an AWS API, you need to sign your request using HMAC algorithm. And the AWS SDK for .NET is using the system.security.cryptography APIs from the .NET SDK to sign your request. Unfortunately, these APIs are missing in Blazor WebAssembly because Microsoft can't ship OpenSSL as a dependency of Blazor WebAssembly. It wouldn't be a good idea. So they are bringing back this API is on the road for .NET 7, but from my last reading, things are not going as they were expecting. So maybe some part of the cryptography API will be pushed to .NET 8. We'll see. So because of this, you can't use the AWS SDK for .NET from your Blazor WebAssembly application because you can't sign your request to AWS API. So, okay, what is the solution? And the solution is BFF to the rescue. And when I say BFF, I don't mean best friend forever, but I mean backend for front-end pattern. Okay. If you use a backend for front-end pattern, you will build a backend for front-end API that will handle the interaction with Amazon Cognito and AWS API server side. And here it's all good. You can interact with AWS Services. And your Blazor WebAssembly application will only interact with your backend for front-end API. So this pattern is more and more used, for example, to avoid managing refresh token on the client side when we are discussing authentication, for example. So you can use it here to work around the issue you can hit with Amazon Cognito and the lack of support of the cryptography API. So let's see how we can build a Blazor WebAssembly with this backend for front-end pattern on a use case. So let's take the use case of I Love My Local Farmer. So I Love My Local Farmer is a fictional online marketplace that allow consumer to buy fresh and local produce to farmers near them. You can find more on this fictional company on ilovemylocalfarmer.io. So the company, when they onboard new farmers on the platform, they request farmers to send them proof of address. Okay, right now it's a manual process. Farmers have to send by mail the proof of address documents, and operators process this document, and once they've validated the documents, they store them in a proof of address database. And leadership of I Love My Local Farmer want to automate this process to reallocate their workforce on more valuable tasks. So the .NET development team is handling this and is building a new application to handle this process. And they've decided to use Blazor WebAssembly because this team doesn't have a lot of front-end development competencies. They don't have much JavaScript development skills, so they've decided to give it a try to Blazor WebAssembly to build a single-page application with Blazor WebAssembly. So the idea here is that the farmers will navigate to the Blazor WebAssembly single-page application. Once the browser hits the URL, it will retrieve the single-page application from the content delivery network. Here, the content will be served by Amazon CloudFront. If Amazon CloudFront doesn't have the content in its cache, it will retrieve the single-page application content from Amazon S3, where the single-page application is stored. Once the application is loaded in the browser, the farmers are able to log in. So when they click on the login button, they will their request will be redirected to the backend for front-end API, and the backend for front-end API will handle the interaction with Amazon Cognito. Once farmers are logged in, they can the application can get a pre-signed URL, allowing farmers to upload their document to a storage space. So the get pre-signed URL request goes to the backend for front-end API, and the backend for front-end API request this pre-signed URL to Amazon S3 using user temporary credential. And once the pre-signed URL is back to the Blazor WebAssembly application, farmers are able to upload their document directly to Amazon S3. So enough about slides. Let's demonstrate this application and see how it works. So here is the application, this Blazor WebAssembly application. I will open the developer tools here on the network side. So if I reload the page, you can see that it's related to Blazor WebAssembly, and here there are stuff related to .NET 6. WebAssembly binaries are not loaded once again because they are cached in my browser, because I've already navigated to this URL. So the WebAssembly binary are already cached in my browser. Now I can sign in. So when I click on the sign in button here, the first request, the login request, I hope you can see it in the hit window. The login request redirect me to my backend for frontend, and then my backend for frontend redirect me to Amazon Cognito. This is where I've landed in. Here I'm asked by Amazon Cognito to log in. So here I can log in. And once I'm logged in, I'm redirected to my backend for frontend API, and my backend for frontend API redirect me to my Blazor WebAssembly page, but with an authentication cookie. So since now I have an authentication cookie, I'm logged into my Blazor WebAssembly application. Now I can select a file here, and I can click on the upload button, and here you can see that my Blazor WebAssembly application has requested my backend for frontend API a pre-signed URL, and then I've used this pre-signed URL to upload my document directly into my Amazon S3 bucket. So let's switch to the AWS console. So now I'm in my Amazon S3 bucket. So before it was empty, and now if I click on the refresh button, oh, sorry, I need to sign in again. Okay, so now you can see that my file has been uploaded into my Amazon S3 bucket. So that's it for my application and how it works. Let's move to the code now, and let's take a look at how it works. So first, I will concentrate, I will discuss the source code that handles the interaction between my backend for frontend API and Amazon Cognito. So let's move to Visual Studio. Not this part yet. So here is my my backend for frontend API. Here is my solution. So in my solution, I have several projects, one for my API, one for the web one is the project host that define my Blazor WebAssembly application, are some shared code. And I won't go into the detail about the config function and infra project. But you will find this code on GitHub. I will share with you the link. It it is currently being published. So it's still under review, but it will be available soon. So let's take a look at my backend for frontend API. So first, a few things to know. So as my application is running in AWS App Runner, so as I told you, AWS App Runner handle load balancing for me. So it terminates the SSL connection at the load balancer level. So if the request is a HTTPS request, and I hope so, I need to instruct my load balancer to forward me the to add the X forwarded for and X forwarded proto header, so that my ASP.NET Core middleware retrieve the original request scheme. It's important. Then I set up the authentication. I define the cookie authentication scheme as the default one for sign in, sign out. So the authentication between my Blazor WebAssembly application and my backend will be handled thanks to the cookie. And here I'm setting all things about the cookie. Just here, because I've deployed my demo app into AWS Services, I didn't set up a custom domain. So I need to define same site mode as none, but in production, you will use a custom domain that allow you to at least use lax mode or strict mode, but at least lax mode. Don't do this in production, please. And then I define my OpenID authentication scheme. So as I told you, Amazon Cognito is not a fully compliant OpenID Connect provider, but it implements most of the specifications. So here on the server side, I can use the OpenID Connect middleware, authentication middleware, and fill all the option with configuration coming from Cognito, and it will work. The specific part here is that Amazon Cognito implement a specific logout path for the logout action. So I intercept the sign-out event and I call myself the logout action with the appropriate path. And that's it for the configuration. Oh, of course, you need to configure cores here. It's important. Once again, because I didn't configure a custom domain so that my backend for frontend API and my frontend run on the same domain. So now let's take a look at the controller, the hot controller. So here in my backend for frontend API, I have a hot controller. It implements 3 actions. First one is get current user. So this action return all the claims of the logged in user. So if the backend for frontend API receives a get current user request, and there is a cookie, an authentication cookie with this a valid authentication cookie, the ASP.NET Core middleware will decode this authentication cookie, and here I will be able to retrieve the user identity claim and put this in a current user object that I will return as the result of my action. And here for the login and logout action, I just return challenge result that will start an authentication challenge, specifying that here I'm not using the default authentication scheme, but I'm using the Cognito authentication scheme. And here for the sign out. I'm doing the same for Cognito, but I'm also signing out the default authentication scheme. Oh, someone is telling me that I'm mute, but I don't think so. Can someone confirm if I'm mute or not, please? Because someone is complaining I'm mute. Can you hear me, please? Can you confirm? Okay. So it's probably someone that this person has an issue. Okay. So let's continue. So this is for the how I handle the authentication. So on the server side. So now let's move to the next part, and now I will discuss the code ending the interaction between my backend for frontend API and Amazon S3 to retrieve a pre-signed URL using the user temporary credential. So let's move to this part of the code. So for this, I've implemented a pre-signed controller. This controller only implements a get action. So here to call this action, I need to be authenticated, of course. And so the first thing I'm doing is I'm retrieving from the HTTP context. I'm retrieving the ID token from the Cognito authentication scheme. So if the logged in user is not logged in through Amazon Cognito, I can't retrieve any temporary credential for this user. But we expect the user to be authenticated with Amazon Cognito. So thanks to this token, I'm building a Cognito AWS credential object. Okay. Sorry. And here I'm retrieving, I'm calling the get credential async method, and it will call Amazon Cognito and ask Cognito to provide temporary credential for the logged in user to interact with AWS services. So by default, the provided token by Amazon Cognito for my logged in user doesn't allow the user to interact with AWS services. But here, by doing this, if Amazon Cognito is configured properly, it will check if I've assigned some permission to the logged in user to interact with some AWS services. Here, in my case, Amazon S3, and it will give temporary credential for me to interact with the service on behalf of the logged in user. So I retrieve this temporary credential, and then I use them to here call the generate pre-signed URL method. And in this method, I'm just building an Amazon S3 client object. So this object comes from the Amazon SDK for .NET. So the Amazon SDK for .NET provide a convenient Amazon S3 client object. I pass to this object my temporary credential, and then I just call the get pre-signed URL method on my client object to retrieve a pre-signed URL that will allow my user to upload its document. So for example, here, when I give as parameter of my request the bucket name, the key, and more importantly, the verb that can be used. So here I can only upload a file, and I define also the duration of my pre-signed URL and the content time I can upload. So this is how I can retrieve a temporary credential and then use them to get a pre-signed URL. And that's it for the backend for frontend API part. So now I will move to the code, the Blazor WebAssembly part, and discuss the code that allow the Blazor WebAssembly application to interact with my backend for frontend API. So let's close the code related to the backend API, and let's move to the Blazor WebAssembly part. So first, you need to configure your startup. So as I told you, the default authentication mechanism for Blazor WebAssembly is built on top of OpenID, but you can build a custom one. And as it's a single page application, the only thing you have to provide to your Blazor WebAssembly application is a custom authentication state provider. So here you build your own authentication state provider, and you instruct your Blazor WebAssembly to use this authentication state provider. Okay? And in your web part here, so this app.razor file, it defines my application, and at the top of my application, I'm using the cascading authentication state component. So this component will ensure that my authentication state is cascade to all my child components. And once I'm doing this, then I can use my authentication state, like for example, in my login display component, I'm using the authorized view component, and this component can has two child components. One is the authorized child component, which will be displayed only if the authentication state says my user is logged in, and the not authorized component that will be displayed only if my user is not authenticated. So based on this, I can decide what to display to the user. So here, when I'm authorized, I display a sign out button. And when I click on the sign out button, I'm calling backend code here on submit sign on. And here, what I'm doing is instructing my browser to navigate to my logout URL API. I'm not calling the logout action from my backend for frontend API. I'm navigating to this URL. It's important. It is very important there. It's not a call. I really navigate to this URL, and the same for the signing action. So this is for the login display component and how I handle the login and logout action. Let's take a look at my authentication state provider now. So I'm implementing an authentication state provider. So here this class is coming from the framework, and it only requires me to implement the get authentication state a thing method. So basically, I could implement a yes authentication state provider that always says that my user is authenticated. I can implement whatever I want in this custom authentication state provider. Okay, so here is what I'm doing. Here I'm calling my get current user method. So this method first check if I've already requested my get current user to the backend for frontend API. If I didn't already requested my current user, I'm using my current user service to retrieve my current user from the backend, and more importantly, all its claims. And so now, if once I've retrieved this user from the backend for frontend API, I'm passing the claims of the user, and I'm building a claims identity object. This object is from the .NET framework, and I'm using this claims identity to build a claims principal object that I'm returning inside my authentication state. So that's it. I've built an authentication state provider, and the only thing this authentication state is doing is just to check if I'm authenticated based on what my backend for frontend API is returning. So let's take a look at my current user service. Okay. So my current user service here does an important thing. It calls my backend for my get current user action from my backend for frontend API, but the trick here is to call this method. If you don't instruct Blazor WebAssembly to ask your browser to include your credential with the request, your browser won't add your authentication cookie to your request. So for your backend API, there is no authentication cookie, so you're not authenticated. So it's really important to instruct your Blazor WebAssembly application to ask the browser to add your authentication cookie to the request to the backend API. Without this, it can't work. So as I'm adding the authentication cookie to my request, the backend for frontend API is able to process the authentication cookie and is able to return the I would say decoded user claim. That's it for the authentication. And now, last part, let's move to my upload component. So the upload component is displayed in my page when I'm authorized. And so this component just first implement a get pre-signed URL method here that will call my backend for frontend API to get the pre-signed URL, and once again use the set browser request credential method to instruct my Blazor WebAssembly API. Hey, add my authentication cookie to this request, otherwise my backend API won't recognize the logged in user. So here I retrieve the pre-signed URL, and when the user click on the upload button, I'm using this pre-signed URL to upload the image. So that's basically a put request using the pre-signed URL, and that's it. That's how I've implemented this application. So it's time to wrap up the presentation now. So what we've seen, you can leverage the backend for frontend pattern to interact with AWS services. You can't interact directly with AWS services from your Blazor WebAssembly application. You need to leverage the backend for frontend pattern. You can deploy your Blazor WebAssembly single page application on Amazon S3 and deploy your backend API on AWS App Runner. In my opinion, it's the easiest way to do. Key takeaway, I don't demonstrate this too much in this session, but you can leverage the AWS toolkit for Visual Studio inside Visual Studio to interact with AWS services. You can leverage the AWS SDK for .NET and extension libraries. For example, here I've used the AWS SDK for .NET to interact with Amazon F3 in my backend API. And you can leverage AWS serverless and container services to make your life easier. And more importantly, try it out. So you can explore .NET on AWS. We have awesome workshop that you can try .NET on AWS. And very soon, it's a matter of maybe a few hours or maybe tomorrow. The code of this session will be published on GitHub, and you will be able to dive deep into the source code and try this application and even deploy the whole application inside your own AWS account. So thanks for your attention, and if you have some question, I will be happy to answer your question now or after the session. And here is my social Twitter handle and LinkedIn if you want to contact me after this session.